the big picture DevOps, how DevOps came in, right? What like how exactly we implement. Like we were having a big picture of what it is all about, right? Today, let's begin with a version control system. Like what is Git? Why do we need Git? Who uses Git and all? So let's begin with what a version control system is. Anyone here who are using it or any thoughts of what it is before I share the actual information? Do you have any idea on what a version control system is? Anyone want to share any inputs? Okay, so let me begin with understanding what a version control system is. Let us imagine there is a project, right? And they were using some files. They have created some configuration files or whatever it is, and they have some shared folder or the shared drive. Let's assume this is the shared location where they have kept all the project files. Let's say file 1, file 2, and so on, right? This is shared across the team. Let's suppose there is a person A who want to make changes to this file. So he got this file from this shared drive to his local system, and he was making the changes. And person B also got the same file at the same time. B also got this file to his local computer and he is making changes. So after day 1, right, A put the file back. After day 2, B kept his changes back to the shared location. Now tell me, after day 2, this file 1 will have which person changes? Here I'm talking about a simple scenario without using any version control system. Both of them got the same file on the same day to their local computer. Both of them made the changes, and A put the file back on day 1 and then B put the file back on day 2. So after day 2, this file 1 will have which person changes?
Person B,
Only person B changes will be there, right? Why? What happened to person A changes?
because it is overwritten by B.
It is overwritten by B's changes, right? Means what is happening here? Person B's changes are overwriting person A changes. Correct? So changes are being overwritten. B doesn't know that he is doing it. Even A doesn't know that his changes are being overwritten. Correct? So in a team, this is quite a quite occurring scenario. Like there might be a file which multiple people might be working on it, and they will make their changes and put it back. And each other, like every person cannot check the file back and see whether it is secure, whether it is safe, whether it is being overwritten. They can't check this, right? They'll have their own task to work on to meet the client expectations and all. They can't work on backup security of their files or the changes they are making, right? So one person, there's a chance that one person may override changes of the other. If this keep on continuing, imagine it's a team of 5 people. Project gets messed up, correct? Project goes messed up at times, right? You don't see the code or you don't see the changes in place. They might be messed up, they might be corrected, which impacts the product, right? So how to avoid this? That's one of the places where version control system comes in, where it allows people work parallelly or simultaneously. Means multiple people can work on same file parallelly, right? That is possible, which is a through version control system. Because this is not possible manually, we can't just see whether my changes are overwritten by someone else or not. So that's where version control system comes in. It allows people to work parallelly on the same file at the same time. Then what else? Another thing is, okay, let's suppose application is working fine till today 7 a.m. Something went wrong and the application was down by 7:15. We need to immediately see what happened, what changes went in between, so that we would revert those changes or remove those changes, right? Means we need to have a detailed logging. Like, okay, person A made changes on file 1 on line number 4, which at 7:05 or 7:10, which led to this application crash or application down. We need to have this kind of detailed logging. Is this again manually possible? That's where again version control system comes in, which provides with a detailed logging, like which person made what changes at what time, right? So that's another thing you have. And another scenario is like, let's suppose, okay, you are working on file 1, it's a version 1. Let's say it's a version 1. You want to make some changes and upgrade it, like client gave some requirements, modifications. You just have overwritten it and made over version 2. There is no more version 1. But after some days, client want to go back to version 1 because version 2 is not working for them, right? But you have removed or you have edited the same and made version 2. Again, rework to make version 1, correct? So what you should have done? You should have taken backup of version 1, backup the version 1, then make version 2. Don't edit and just make it version 2. Have a backup of version 1 so that at times if you want to go back to the previous versions, restore the previous versions, it will help you. So all of that are possible through version control systems. So logging, backing up, maintaining the version, securing the code safely without one person overriding the changes of the other, all of that can be taken care by a version control systems. So now, which files are this? Any files, any static files can be version controlled. It need not be Java or only .NET. It could be anything, Java, PHP, Python, even simple text files also can be version controlled, right? Any file can be version controlled. So who uses it? Obviously, it's a developers, it's a life of developers, but even testers will use it because they do have automation test scripts, right? They are doing automation testing. They have automation test scripts, test cases. So even testers use it. Even ops teams uses it to store their scripts, to store their config files. Same is the case with the DevOps people. As a DevOps person, we'll be having Kubernetes manifest files, right? Ansible playbooks, Terraform config files, all of them should be version controlled. So I believe anyone working in IT should learn version control system, irrespective of your role. Everyone should learn it to manage your files. Is this much clear, everyone? Are we good?
Yes.
Yes.
So everyone have to use it. This is one perspective of learning version control system. Okay, because I'm a DevOps person, I want to manage my files, I want to manage my project, I'll learn it. Yes, developers will learn it for the same reason. This is one perspective. Another perspective is, yes, we will have developers, a separate team who write the code. They write the code and they maintain this repos, right? Or else, okay, they will push the code to version control system. As a DevOps engineer, you will also have you use it to store, let's say, your Terraform config files. Let's suppose, okay, this is another repository in the version controls. Imagine this is another folder, this is another folder. So whenever developer make a change and push to version control system, as a DevOps engineer, it should trigger the CI/CD pipeline. Yesterday, we were talking about this, right? Whenever developer make a change, it should automatically trigger the pipeline, build it, execute the test cases, deploy it and all. So how do you, whenever developer push the code to version control system, as a DevOps engineer, how do you build the CI/CD pipeline to trigger it, pull the code from there, build it, execute test case on it, deploy it and so on, correct? Means you should learn it from the perspective of the DevOps through CI/CD. That is the another perspective. We will learn both of them in and out thoroughly, right? So first we'll begin with managing the projects, managing the files, because that's where you should begin. First learn version control system, then we'll see integrating it and creating a CI/CD with it. I believe it's clear for all, right? So those are the two perspectives we'll be learning. First, we'll get started with managing our files. So here, as of now, we did not have Terraform files. We did not have Kubernetes. We did not start those yet, right? So we will learn with some text files, some dummy files, because whether it is a text file or whether it is a Java file or whether it is a Kubernetes config file, Kubernetes manifest file, whatever it is, the way you manage the files, the concepts are same. So first we will learn with some text files, and then once we learn Git and we get started with the pipelines, and as we progress with our different automation tools like Kubernetes and all, We will use the same Git to apply it for the real files, right? We'll get started with some text files. So whatever the file is not the point here. So yeah. So then version control systems based on their architecture were categorized as centralized version control systems and distributed version control systems. Centralized version control system and distributed based on their architecture. How they were different? Let's see. If you see here, based on their architecture, they were categorized, right? Centralized version control system is nothing but which will have a central server or a remote server. This is the central server or remote server where all the project work would be kept. If you are thinking as a developer, think that it's your code base. If you are thinking as a DevOps engineer, yes, this is our config files, whatever it is, our project. So there will be a central server where all the project files would be kept and that would be shared across. Means this is the individual collaborator or user. You may consider them as a developer if you are into development or DevOps. So these are the workstations of individual users. They will connect to the remote server, get the code locally, get the files locally, make the changes and put them back. Simple architecture of central version control system. The drawback is you need to have the network connectivity always. If you don't have network connectivity, entire work is halted. Means you should be connected to the central server always. If you don't have this network connectivity, entire work would be halted. That's one of the challenges. And the other challenge is, let's say this central server got crashed. Okay, or something happened, this got destroyed, entire work is lost because it works like a single source of truth. Right? So if this is lost, yes, there is no chances of recovery or less, very less, because it works like a single source of truth. So these are the drawbacks or challenges of centralized version control systems. To overcome this, we have got distributed version control systems. Can I go ahead to distributed?
Yes.
So in distributed architecture, if you see, again, this is called the central server or the remote server where all the project work is kept. And this is the workstation of individual collaborator, means each DevOps person or each developer, whatever from which perspective you think about. Yes, these are the workstations of individual collaborators or users, right? And again, if you observe, every user is having a copy of the remote repository, which is called local repository. This is called local repository. This is called remote repository or central repository. All the project work is kept and you will have a copy of it in your local computer, right? And then you will not directly work on it. You will work on another folder or a directory called working directory. You make changes here, then push to local. From local, you push to remote. This is the hierarchy. From here, changes goes in here, from here to here, right? So means distributed. In distributed, everyone is having a copy of So this is the architecture of distributed version control systems, right? And here, if you see, you will be getting a copy from remote, right? And only once your changes are complete, you push to remote. Means you don't need network connectivity always. Even though network connectivity is not there, you can still work on local. Entire work is not halted, right? Only once your complete work is done, you will push to remote. Means if you notice here, this pull and push are less frequent. You push once, you copy once and create a local. And once your complete work is done only, you will push to remote. You don't push to remote very regularly, right? Most of the times you work on local repository. Most of the times you work here. Most of the times you work here. So even though network connectivity is not there, you can still work here. But to pull, you need it. Pull and push are less frequent. Am I making sense? So
Yes.
that's one thing. Even though network connectivity is not there, you can still continue working on it. Only to push your changes to remote, you need the connectivity. And another thing is, as majority, most of the time you work on your local computer, it's just accessing your hard disk, right? It's quite faster. And also, let's say this remote repository is crashed or gone for some reasons, right? Everyone is having a copy of remote, right? Chances of recovery are more. These are some of the advantages. These are some of the advantages of distributed version control systems. And another thing is, as long as the changes are in your local repository means this one, right? Others don't see those changes. Only once you push them, you move them to remote, then only others can see the changes, right? These are the advantages of distributed version control systems. And Git comes under this category. Git is a distributed version control system. And all the most of the modern DevOps projects uses Git. That's why we were learning Git. Right? Yes, Surya, Git changes the pushes. It's nothing but version control system. Git is a version control system. I believe, see, you got an idea of this architecture, right? Let me also differentiate. There were many version control systems. That's what I'm talking about, right? Under each category, there were so many. Git, Mercurial, Fossil, these comes under distributed architecture. Then what are centralized version control systems? TFS, SVN comes under centralized version control systems. Understood the difference? And also, see here, this is the graph. This is the graph from Google Trends. This is the graph from 2020. You can also get the latest graph. This is a comparison between different version control systems. Sorry, yeah. Like Git, SVN, TFS, Fossils. You can see that Git is clearly winner in the category. It's a market leader. That's why we are learning it, because majority of the projects uses Git. Even though if you master Git, even though you are asked to use SVN, it will be very simple. They are similar tools with a similar analogies and concepts. Switching over to other tools would be self-explanatory. You can also check out the latest graph. Give me a second. I'm sorry, I'm just trying to share the page. See, this is the latest graph. Right, Git, SVN, TFS. If you see again, Git is clearly very widely used. You can see here Git on an average over the time. This is the latest one. You could also add. Right, so you can compare the tools this way. All right, let's continue. Yeah. So now that we understood the architecture of version control systems, let's get into the architecture of Git in particular into detail. So coming to the Git architecture, like we discussed, it will have two repositories, the local repository and the remote repository. See here, let me grab the marker. So this is the remote repository, right? And this is the workstation of individual user who will have local repository, working directory. Now here you can see working directory is nothing but another folder on another directory where we make the changes. And how do you move your changes from working directory? This is not possible. Means you cannot just from working directory, you cannot push something to local repository. This is not possible. Then what you should do from from working directory, you should move your changes to something called staging area. What is the staging area? Staging area is nothing but a virtual layer, or else it's called as index area. Index area or staging area. It's like you might be asking, what is the importance of it? Why do we need it? It is like a preview or else a pre-check before your changes goes to remote. I'll talk about it in a while. Just understand from working directory, you should move your changes to staging. From staging, you should move to local. From local, you can move the changes to remote. It's called GIT tree. It's a 3 steps before your changes goes to remote repository, right? And the staging area is like a virtual area or else index area. It's like a preview, pre-check before your changes goes to local. Let me give an example. Suppose in working directory, you have 10 files, but if you want only 5 of them to go to local, so you will move only those 5 files to staging area, right? So you'll have a better control on instead of directly moving them to local, you will have a layer between so that you could recheck, you can check what changes are going to local. That's how it works, like a preview or a pre-check, or it will give you a better control on what changes are going to local. See, this is all theoretical. In few minutes, we are going to jump into hands-on and I'll demonstrate you all of these parts like working area, local repository, staging area, all of that. Right? So this is how the changes moves from working directory to staging. So this is how changes moves from local to remote. This is called GIT tree, right? And then, yeah, I'll tell you another interesting point. Can I proceed or anyone have any questions? Okay, let me talk about how is local repository created. There are 2 use cases or 2 scenarios how local repository is created, right? Let's say, okay, you already, let's take one use case. Suppose you joined a project. Okay, it's an old project, it's some 2-year-old project, already it's working, DevOps is implemented there, you joined as a new team member. So already there is something on remote, right? So you are asked to make some changes. So you will copy from remote and create a local repository, right? That's one use case. Another thing is, let's suppose you joined the project. This is second use case. Let's say you joined a project. It's a completely new project. They're starting from scratch. You joined there as a team member. There's nothing on remote. It's a fresh project. So you have to create a local repository, create an empty local repository, make your changes, then push to remote. So those are the 2 use cases or scenarios how local repository can be created. Am I making sense? Everyone, is this making sense?
Yes, Preeti.
Appreciate your quick responses. If you have any questions
Yeah.
or confusions,
Can you please repeat, Priti?
this part, local repository creation?
Yeah.
Okay. Yeah, 1 second. So local repository can be like we were seeing this, right? This part, I'm talking about this part. How do we create it? Isn't it? How do you create in your local computer? 2 use cases are there. Let's say you joined a running project. Already project is running. You just joined as a new team member, right? So how do you do that? You just copy from remote and create a local repository. Simple. How do you copy? We will learn. We are going to demonstrate all of that with a hands-on. So you just copy from remote and create a local. That's one use case. Another use case is, let's say it's a new project. You joined the new project. There's nothing on remote because it's completely new. They have to develop it from scratch. There will be nothing already. Project folder will not be there, right? So you have to create an empty local repository. Everyone will do it. They'll create their empty local repositories. Let's say you are asked to create some Terraform config files for EC2 instance. You will work on it. Someone is asked to work on Terraform config files for S3. They'll work on it. Everyone will create their own empty local repository, develop their config files, then push to remote. Understood?
Yeah.
So
Yeah.
those are the two use cases how local repository can be created. We will learn both the use cases. First, we'll be getting started with this. Anyway, we are new. Assume that project is new. There's nothing on remote. So how do you first create your local repository, an empty one, then create some files, and then like how do you push to remote? That's how we'll begin with. Then we'll talk about the first use case for the demo. Is it clear now for all of you? Appreciate your quick responses, your queries,
Yes.
anything you have, feel free to respond.
Yes. I just have one additional question. I mean, since you mentioned about distributed version control system, right? And there is also this possibility of, the network going down and so on. So in that case, don't you think it is as good as, having a centralized version control system or no versioning in place? Because
Have you
how,
just joined, Ritesh? Have you just
yeah.
joined the class? Okay. I
No.
just covered.
No, that's fine. I was there right from the beginning. My
Okay.
only question was that even if in case of distributed version control system, I mean, what is the possibility of the failure? My question is that maybe if you want, you can reserve it for later. That's fine for now.
No, what I think is like even though network connectivity is not there, let's say you don't have network connectivity, you still can work on local, right? Of course, push and pull will be impacted.
Correct,
These
correct. No,
things will
yeah.
be
I mean,
impacted.
I can also work on my local, and you can also work on your
Hmm,
local, right? But when
correct.
you try to merge,
Hmm.
then don't you
Then it will
see?
be a problem. Then it will be a
Yeah,
problem. But
yeah,
when compared with centralized, at least you can continue working on your local here. That's not the case with central. So I'm talking
right,
about the differences. These will be
right.
impacted for sure.
Okay, understood. Yeah, I mean, I just wanted to understand that. Fine, fair enough. Good.
Sure. So these are the use cases how local repositories can be created, right? We were talking about working directory, we were talking about staging area, local repository, how locals can be created and all. Let me talk about another interesting point before we jump into the demo. Another interesting part is, like we were talking about these like folders, right? But working directory, local repository is physically one and the same folder or same directory. Right? You might be surprised with this. Then how come you say it's working directory? How come you say it's a local repository? Logically, they are different. How they are different logically? Let me tell you. Let's assume this is a folder. Okay. Let's say, okay, I will create some folder called Git demo or else my project name. This is where I'll put all my project files, right? I just created a file. When I just created a file, I'll call it as working directory, right? Yes, I just created a file means it's set to be in the working directory. After that, if I have added that file with this command, means if I run this command, then it is set to be in the staging area. Then if I run the command git commit, then only we'll say it is in local repos. Physically, it's the same folder. This git demo is nothing but your working directory. That git demo is nothing but your local repo. Git demo or whatever project folder name. You may give your project name. Let's say my project name is something like fcaps, right? The same folder is the working directory. Same folder is the local repos. Physically, file is present in the same. But you just created and left it means we'll say it's in working directory. If you run the command git add that file, then it is said to be in the staging area. If you run the command git commit, then it is said to be in local. Understood? Physically same, but logically they are different. Is that making sense? It might be a bit interesting. It might be a bit new to you, right? We'll see this with the demo, but this is the theoretical part of the architecture. Let's go with the demo to understand each part here. Let's begin with the hands-on so that will clarify all of your questions and it will bring a lot more visibility. And here, let me tell you, first, let's go and install Git. Git works on multiple operating systems. It works on Windows, it works on Linux, Mac, and so on. So for learning Git, you don't need to go out for AWS or create some instances. You can use your local computer. But how to install Git? Let's get started. Can we go on?
Yes, Preeti.
Okay, I'll come back to this architecture. Okay, it's not yet done. I'll refer the commands with this in a while. Now just go and install Git. How do you install Git? Already the commands, everything are there in the Google Drive. We'll share it with you, but also see the process. Just type in Git downloads, go to this official website, gitscm.com. Here you can see downloads. Let's say yours is Windows. Okay. Go here, download the Windows executable and run the executable. It will launch a wizard. You should go click on navigating. I'm pretty sure you all know how to download the executable and run the executable on Windows. Still, if anyone new to Windows or if you need any help, you have this documentation available in the Google Drive with the screenshots. Do you see that? You have to download this and double click that. You see here, click on Windows, download, you will get this executable in your system. Just double click that. You will be launching with this wizard. Click on next and go on. That's all. That will install Git on Windows. Then let's say you have Mac. Then how do you install it? Just simple brew install Git will do. Open the terminal and run this. See, only installation differs. Once installation is done, the concepts, commands of the tool are same, either it is Windows or Mac or whatever. So just set up according to your operating system. Let's say if it is Windows, depending on, Linux, depending on the distribution, here are the commands. So that's how you install. Yes, I'm using Mac. I have Git installed. Once it is installed, if you run the command git, it will show you a lot of verbose, means Git is installed. If you want to check the version, git -- version. Done. I have Git installed. Now let us learn Git. And by the way, I'm using CLI here. Like CD means going back, one level back. I'm on my desktop. Now I would be creating some folder here to work with it. Let's suppose I already have this. I'm just removing. See, you may create from the CLI if you are comfortable. Let's suppose you are not comfortable with the CLI, you are using Windows. You can feel free to go to the folder and create a folder from the GUI. Anything is perfectly fine. I believe you are following what I'm saying. You just go here, right click, okay, create a folder this way. Perfectly fine. If you are comfortable, you can use CLI. Anyway, we will learn Linux basics and the CLI thoroughly. Until then, you may use GUI. mkdir, make directory. This will help you create a directory. Even you can use this in Windows also from command prompt, right? So I believe you are all good with it, at least the basic part. So I'm creating a folder called Git demo. You may create anything. It need not necessarily be Git demo. Maybe your project name or else whatever you want. Create some folder. See, Git is installed on my system, but now I have to tell Git which folder it should version control. Am I correct? So create a directory called Git demo. See, it is created. If you are good with the GUI, you can use GUI only. That is also good. Now go to that folder. How to go to the folder? I believe every one of you know the small CLI commands. How to go to this folder? How to go to any folder from the CLI? Either it is Windows or Mac.
The CD and then the folder name, Preeti.
Right, that's all. So just go to that folder. Right now, PWD means present working directory. You are in the folder. So what I have created a folder and I want to tell Git to version control any files here. Means I want to make this as a local repository. Right? How do you make any folder local repository? Go to that folder, run the command git init. Git init means initializing Git, starting Git. Also, see, I'm creating local repository. Some time back, I'm talking about this, right? Like, okay, I have erased it. Okay, some time back, I'm talking about, assume it's a new project. You can create an empty local repository. That's what I'm doing. This yellow box, I'm creating this local repository. Okay, here it is. Okay, I'm talking about this use case, right? Creating an empty local repository because it's a new project, there's nothing on remote. So how do you do that? Git init. Go to that folder, run git init. It says this, initialize empty git repository. Means, yes, this has become an empty repository. If you see the hidden files can be seen with ls-a.git is created. Right? .git is created means, yes, this particular Git demo is nothing but a local repository now. Understood, everyone? You may also check this way. This is where I have created Git demo. See, do you see .git here? Right? So that's nothing but local repository created. Local repository is created. Perfect. Okay, local repository is created. Git demo is local repository, but I don't have any files. Let's create some files and see where is working directory, where is staging area and all. Let's see that. Let me create a file. Again, I'm telling you to avoid any confusions. You may right click here and create a new file. Okay. Or else from the CLI, if you want, I'm using touch. Create a file. You may create any file. If you are a developer, create a file of your choice of any programming language, or if you are a ops person, create any script files, or if you are completely newbie, create a text file, because whatever be the file, it's irrespective to us. Here we are learning how to manage the files, the file irrespective of the file content or the file type. So for our learning purpose, you can create text files. Later on, we'll be creating our Kubernetes files and so on. So I'm just creating a text file. Okay, some file is created. Now, where is this file? Is it in the staging area, working directory, or local repository? Can anyone recollect
It's
that?
in the working area.
See here, this part we just discussed sometime, right? Just created the file means I just created the file. It is to be in, let's see. How do you know? Okay, I have created a file. How do you know? There is a command called git status. Now, if you come here to the bottom part, it says untracked file. Means Git know there is a file, file 1, but Git is not tracking it. Right? Git knows there is a file, but it's untracked, and it is saying nothing added to commit, but untracked file present. It is giving you a clue. Use git add to track. Means there is a file in this folder. Git knows that, but Git is not tracking it. For Git to track it, add it. It is asking us to add. Means, can you relate where this file is? See this diagram and tell me. It is asking us to add the file. Means, where is the file?
Working directory.
Obviously, see here the diagram, architectural diagram. It is asking us to add the file. Means it's not yet added. Means it's in the working directory, right? So you can add the file now. Let's say, let's run the command git add file name. As of now, the file is in the working directory. Now, if I do git add and then check the status, see, message got changed. Now it is asking us to commit the changes. Means, where is the file now? Always refer to this architectural diagram and learn Git. Where is the file now? It is asking us to commit.
It's in the staging area now.
It is in the staging area because it's asking us to commit, means it's in the staging area, right? So here you can see changes to be committed. Changes are not yet committed. So how do you commit it? Git commit -a, okay, -m. M means message flag. Message is mandatory. I'll talk about this message in a while. For now, put some message which is mandatory. And it says it is all good. 1 second. Now, if you see the status, it will give you working tree is clean. Means if you do ls, this file is present. The same file is present in local repository as well. How do you know? Git ls files will list the files in the local repository. See, but physically, this is the same. Do you see that Git demo is the working directory? Git demo is a local repository. It's a physically same folder, but logically, this is how it is different. Interesting, isn't it? I'll repeat this with one more file so that it should be clear for all of you. Okay, let me just create another file, file2. Now I want you guys to answer. I want to hear from every one of you. Can you tell me where is this file? I mean, whether it is in the working directory or staging area or local repository. I want to hear from every one of you. Unmute and please speak out.
Working directory.
Working directory, Kriti.
Exactly, right? This is in the working directory. How do you know? You can confirm. See, it says untracked file. Untracked means again, it's a new file. Git knows there is a file, but Git cannot track it. It is asking you to add it. So where is this file now? File 2 is in the working directory. Logically, physically, the same folder. Because the same folder is the working directory, same folder is the local repository. I just created a file and it's untracked. It's asking me to add, means it's in the working directory. You can also confirm like this. ls will show files in the folder. Git ls files will show the files in the local repository and staging area. See, file 2 is not there in the local repository and the staging area. Got the difference, right? Every one of you. I want everyone to be clear with the concepts. Concepts should be crystal clear for everyone so that help you to switch over the project, switch over your career, work on the projects comfortably. Is this clear, everyone? A thumbs up will also do if you can't unmute.
Yeah, good.
Right? Yeah. Right. So now what should we do? How to move it to the staging area?
Git add.
Git add that file. Now where is the file? Can you tell me?
Staging.
Absolutely. It's in the staging area. See here, file 2. It's in the staging area. Now what you should do? Git commit.
Commit -t.
Yeah. And what should be the message here? Okay. File 2 or else second file, something like this. Done. Now it is in the local repository. Understood now? Now this architectural diagram which we have learned theoretically should be clear, right? Both are same, how they are same and all should be clear for you now. Right? So working directory, local repository, both are same folder. Logically, they are different. And you move your changes to staging and then to local. We did not push to remote it because before going to remote, we have to learn many things. So we were working on this local repository. We did not go to remote it. So that's how you have your like a local repository and all. And till now we have committed twice, right? So whenever you run the commit command, a commit ID will be generated, which is alphanumeric. That's called commit history. You can see all the commit history with the command git log. See, every commit will create this alphanumeric ID, which is unique, including the author name. That's how I logged into my system, like my system ID. Timestamp. I told you, right? Some time back, it will help in logging with the timestamp, with the details of what changes went, correct? This is how you see the log. Log will show you the commit history, including the timestamp and the person who made the changes. Of course, it's a local, so obviously I'll make changes. And this is the commit message. Commit message is important because, like, let's say after a week, if I check the log, I should understand what this change is all about. I may give a reasonable message here. Like maybe I'm working on Terraform config for EC2. I may write, okay, EC2 changes or else S3 changes kind of, right? So that's how we'll understand using the commit messages. This is how you can check the detailed log. Also, of course, we did not push to remote it. If we push to remote, you will see the log of all the changes whoever other persons made also. But the concept or commands are same. We did not push to remote it. We'll go there. And if you want to see just the brief log, a simple log, log one line. See? Only first 7 characters are enough for each commit. These 7 characters and the commit message. And if you want to see, okay, what changes went into this commit, git show commit ID, first 7 characters. See, it will show you what changes you have done. Because I did not make any changes, it's an empty file. It was showing this. Are we good? So you have to understand here, Git works with respect to changes. Every change will be first in the working directory, then it goes to the staging area, then it goes to the local repository. Until now, we have seen creating new files. It may not be always new file, right? It might be modifying a file. Am I correct? So let's look into modifying a file. Let's say I'll modify this file 1. Like I already said, you can go to your file. You may open this way from the GUI, right? And modify the file here. Okay, let's say I'll put some line and save this. Okay, done. I made some changes to the file. Now, I made the changes to this file, right? Now let's see the status. See? It is giving you something like changes not staged. What does it mean? Changes not staged means where were your changes? Can you refer this diagram and tell me? Always this architectural diagram should be at the back of your mind. So
That means on the working directory.
working directory, right? Changes not staged means they are in the working directory. So here the point to note or the point to catch here is whether it is a new file or whether it is a modification, whatever be it, it will be first in the working directory, then you have to move that change to staging, then to local. So it's telling that changes not staged, so you have to commit. But it's not telling you untracked file. Do you see the difference? Earlier it used to tell like untracked, but now it's not telling that's untracked change, if you see the difference. So what is the difference between untracked and unstaged changes? This could be another interesting interview question. Okay, untracked. Untracked and unstaged. What is the difference? Untracked means it's a new file. For the first time you have created, it's not added into the staging area. I mean, yeah, it's completely new. Unstaged means file is already there in the staging area, isn't it? File 1 is already there in staging area, but some modifications were there which are not staged. In such cases, it will be showing like unstaged. Modifications were there which were not added, right? So in that case, what you can do in both the cases, first, if it's untracked, you have to do git add and git commit. Here also the same. You have to do git add or git commit. But here in this case, because it is unstaged, you can do with a single command, git commit minus a message. You can do this. Add and commit. Sorry, add and minus a means add and the message flag. You can do this way. But for untracked, you can't do it. Got the difference, everyone?
Yes.
Differences between unstaged and untracked. So for untracked, you can do either ways. You can do it separately or with a single command. But for untracked, you can't do it. You have to do separately only. So because it is unstaged, shall I use a single command? Yeah. Git commit minus AM and okay, file modified. File modified. Done. Now, yes, it is committed as well. If you see now, it's a working tree clean. Means yes, now the changes are into local repository. Is this much clear, all of you? Got it right? Any questions? Yes?
Yes.
Right. And one more thing is, let me show you the history, like all the commands we have used. We were running this command, right? For the first time when you run this command on your system, because it's not first time for me, it doesn't ask me. But for the first time when you run this command, it may ask you for the username and the email ID for tracking. Because see here, git log, if you see, it is showing you some email ID, right? I mean, sorry, some username and email ID. This is the email ID it has taken. So it will prompt you, particularly in Windows, it will prompt you for those details. So you have to run these commands. These commands are there in the Google Drive, which you will get, which you will be having for your hands-on user dot name and some name. With that name, it will keep tracking. I have already done that, but that's only one-time task, right? So for the first time, it will ask you. Similarly, user dot email. During the hands-on, you can use it. And also, like after the class, you have to watch the recording and do the hands-on to make your hands-on more easy and comfortable. Like yesterday I have shown you, right? I just want to show you that once again because you have to go with the hands-on. Just let me. Yeah. Here are the pages. Here are the commands you have. Git. Okay, installation commands, hands-on commands, whatever we are using, working directory and all the commands are here. Apart from this, if you go to the website, here also you have, like if you go to the lab exercises and we are doing it. So Git lab assignments, if you go, here day one, whatever we have learned, installing Git, configuring Git, creating a sample project, and commands ls minus a, meaning of it. Every command is explained so that it will be for you to register to go through these commands and learn it. See git log online, what it will do, everything is there. And the day one assignment, if you click on this, sorry, that needs a login, but yeah, here are all the commands, whatever I have executed in class. Okay, day one is open. Yeah, so downloading Git on Mac, exact commands, everything were there. Like make dir, sample project, cdd, what it will do, right? Everything is here. Whatever I have done, including explanation of the command so that your hands-on could be very quick. Before you join the class tomorrow, you're expected. See untracked versus unstaged changes, right? Hands-on with it, everything you have. Hope that will help you. Definitely this lab exercises are helping students to complete their hands-on on time quickly. Okay, there's a question from Surya. Okay, I answered this question. All right. So coming back here, yeah. So that's how you work with the files. Similarly, you could also see the changes on the files. Can I go to the next topic or any questions from anyone? Can I go ahead? Can I move on? Right. Okay, we'll look into another interesting part. Okay, we have these files created here, right? And now let me just do one thing. I'm creating one more file, touch file 3. Now, can you tell me where is this file, file 3? What would be the message of Git status in this case?
It's untracked files and it will be in the working directory.
Untracked file because it's a new file. So what should I do?
Git add.
Git add file 3, right? So file will be added. If you see that, it will ask me to commit. I'm just committing another file, okay? -m, let's say third file. That's a message I'm giving. Done. So I have got the third file. I just want to do some experiment with the third one. Let's say I just want to modify it. Okay, let me just go and edit, do something like this. Hello, okay, something. You may add anything of your choice. Content is irrelevant to us. So I just added some line. Now, obviously, it's like repeating the scenario. Can you tell me where is the changes of this file? Where are the modifications of file 3? And what would be the status message telling us?
It's in working directory, unstaged.
working directory and unstaged. It's not untracked, but it's unstaged. I believe you're all clear with the differences by now, right? So yes, it's untracked. Now you have file 3. Now tell me one thing. Is it having unstaged changes or not? Obviously, right? It's saying changes not staged means yes, it's having unstaged changes. To see the unstaged changes of the file, git diff file name will show you unstaged changes of the file. See here, hello plus hello, it's an unstaged line, right? So yes, it's having unstaged. Okay, fine, I want to stage it. What is the command?
Git add.
So that line is staged, correct? Any unstaged changes are there on this file now? Does it have any unstaged changes?
No.
No. See, diff command output is, there is no output because it doesn't have unstaged changes. Let me do one more thing. Now again, I'm going to this file. I'm again making one modification. Now tell me, is this file having unstaged change or not?
Yeah, it does have.
Right? It is having. Now see the unstaged change. See, diff is showing unstaged changes. At the same time, this file is also having staged changes. Some changes are staged. Correct? Yes or no?
Yeah.
So to see the staged changes, git diff staged flag. See, this line is staged, whereas this line is unstaged. Means simple logic. First line I have added to the file, then run git add command. So it is staged. Then I have added second line, but I did not stage it add. So obviously the same file is having some changes staged, some changes unstaged. At this point, if you see the status, you can see the same file under changes to be committed means which area is this? I mean, where is it? Changes to be committed means?
Staging.
Staging.
Changes to be committed means staging area. Changes not staged means
Working.
working directory.
Working directory.
The same file is shown both under staged and unstaged. This is the simple logic. So don't get confused at times if you see the same file both staged and unstaged. It's quite possible, right? Changes to be committed means yes, it's saying file 3 is in a staging area, and changes not staged means it's saying same file is under working directory. It's quite possible. Possible or not? The scenario we have just seen, quite possible. So you shouldn't get confused when you see something like this, like staging area, the same file under staged and working directory. Are we clear with the scenario? Simple scenario. I have modified, added one line to the file, run the command git add, the change is staged. Then again, I modified the file, added second line, but I did not run git add till now. It's in the working directory. Are we clear with the scenario, everyone?
Yes.
All the participants, can I get confirmation from each and everyone?
Yeah, yes.
Thank you, Alan, Ritesh, and whoever confirmed. Anyone else, like any questions, confusions, you can feel free to ask. So this is what you are seeing. Now what you should do, I should add and commit, right? So git commit minus AM. I can do because it's not a new file, right? File changes for demonstration, something like this. Done. Now you can see it as working directory as clean. Got it, everyone? Understood?
Yes.
So git ls will show you the files here. Git ls will show you all the files. Hope this is clear for everyone, this use case. Again, like you should have a clarity and good understanding on such minute things also to gain grip over the subject. Just give me a second. So whatever topics we have covered here, you can take up the quiz. Let me share you the quiz so that you know the flow from tomorrow onwards. Like you can, whoever got access to this portal can take up the quiz from your end. Go here and this is the quiz. I'm sharing it in the Zoom chat. Whoever doesn't have access or whoever can't access this page, I'm sharing this. You can go through the quiz now. It's a simple questionnaire so that it will help you register the concepts and evaluate the things. Can you just go through it now and submit it so that we would also receive the scores? So topic wise, that is all for today. We have learned about the Git different components, the architecture of Git, and we have seen that in practical. These components are what we have gone through, right? Working directory, staging area, and local. So we have seen like how to create a local repository using the second use case. And we have seen like how staging area, working directory work, and we will see more use cases on multiple people working on it, right? Like how do you push, pull? We did not go to remote it. Okay, that's why we did not go to first use case. First use case will be covered eventually. So that's what we did. Okay, let me give a summary of what we have learned today. These are the things we have learned today. We have learned what is a version control system, types of version control system, architecture of them, architecture of different version control systems, then architecture of Git in particular, right? Then we have discussed about working directory, staging area, local repository, and we have seen creating of files, adding the files, committing the changes, and checking the status, checking the log commit history through log command, checking a brief log. These are the commands we have seen. And of course, cd, mkdir are small commands to navigate. Also to see the files in the staging area and local repository, git ls files. This is the content we have learned today. The expectation is the recording will be available in a couple of minutes. Go through the recording once again. Particularly if you are new to this topic, definitely go through the recording. Do the hands-on. To do the hands-on, you don't need to struggle. You have all the sources, all the materials handy available here. All still, if you need any help, if you are stuck up, you will be having a separate WhatsApp group where you can post your queries and all. And once recording is done, once hands-on is done, you could take the quiz again so that correct whatever you have answered incorrectly today. So this is the flow. That's how it should progress every day. Tomorrow we'll deep dive into the concepts like multiple people working on the files, Git. We have many things like a revert, rebase, reset, and then we'll go to remote. Before going to remote, there are many things to learn. We will go in the flow. Once the complete Git is learned from the perspective of managing the files, then we will put in integration to the pipelines. Any questions from anyone? Just a simple and a small questionnaire to quickly register the things.
Kirti, just one in the Google form, right? The last question, after the 10th question, there is something called based on the text above your fourth question.
No, just please ignore it. I'll remove this. I don't know where it came from. Is it not allowing to submit?
No, it's allowed.
Okay, I will clear it. So any further queries you have, if you want to discuss anything, you can reach out to Mr. Raj on this number, or else you can reach out to me for any technical queries. You can, until a private WhatsApp group, if you are until you are moved to the private WhatsApp group, you can post your queries on the same WhatsApp group as well, the general group. Anything else from anyone?
So Priti, I mean, in the coming lectures, where we are committing and all those will be configured, right? I mean, the servers and so on.
Come
the
again, please.
centralized- No, no, where we will commit all these files, right? So that will be configured, right, in the eventual lectures.
Yes. Actually, we were learning Git now. So whatever be the file, we were using text files. Tomorrow, our Terraform config files, Kubernetes config files, we make changes and commit them. The same concepts would be implemented on the real files. That's why we were learning Git first, so that we could use it for our projects as we could progress.
Yeah.
Any more questions from anyone? All right, then go through the quiz and submit the quiz. We'll also receive the scores and you could retake the quiz accordingly, right? All right, then. Thank you all. Good day. See you all tomorrow. Bye, everyone.
Thank you.
Bye-bye.